and welcome back to ReddyControls. I indicated in the last video, we showed the process of developing logic for a sequential machine using something called as a Pullman sequencer. In this video, I'm going to show you how to write this logic all the way from input mapping to transition and output control in Studio 5000. As we looked at last time, a sequencer allows us to break down the machine sequence into steps, and each step has a transition condition. Each step has an output condition or actions, and then each step has a transition. Once the transition condition is met, the sequencer will move to the next step. As we saw in the previous video, our simple example of parts washer will have a idle step. When a push button is pushed, start push button is pushed, will sequencer will step into step 10. Upon step 10 in where we've opened the inlet valve, and once the inlet valve is open and tank is full, tank full condition is the transition to go from step 10 to step 20. And in step 20 we heat the water, and once the water is hot enough, the transition condition of water temperature greater than or equal to 50 is what we use to index from 20 to 30. And in step 30 is where we have an action of turning on the outlet valve to wash the pot. And once the tank is empty, which is the transition condition, we are going to loop back to step 10 if there is no stop condition. But if there is a stop condition, we go back to step 0 and stop. So now let's get into the code. So what I have here, I have a small demo. I'm going to show you how we are using this demo unit. I have a normally open push button wired to a start PB, and a normally closed red button which acts as a stop condition. The green light indicates the machine is in auto cycle. The red light indicates the heater is on. The blue light indicates the tank is being filled with water. So coming into the logic, I have a simple start stop logic here, a start push button with a seal-in condition of auto cycle start, and a stop push button which is normally closed in an auto mode. Okay, and the auto mode is, I think I used the switch one for auto manual. So now the machine is in auto, and once we hit the start condition is when we could see the auto cycle start sealed in. Going into the sequence, the first step I'm doing here is I created a tag called sequencer, which is of a integer type. And whenever the sequencer is in step 0, that means it's in idle. If it's in step 10, it is in filling step. If it's 20, it is heat, and 30 is for wash, right? So all I'm doing is whenever we hit a reset button or we hit a stop, we want to move the sequencer into a idle step. That's all we're trying to do in that logic. So whenever I hit a stop button, you could see the sequencer is reset to 0 or initialized. Or whenever I hit the reset button, the move statement will move a 0 into sequencer. Okay, make it a little bit big. Okay, that's a reset or an initialization logic. Nothing complicated there. Now comes the first transition condition. We were in step 0, and our transition condition to go into step 10 is we being in auto cycle start, or the machine being in auto cycle start. So I will hit a auto cycle start button. You could see the sequencer moved into step 10. Make sure you use a one-shot rising or a ONS one-shot bit to make sure you don't keep overwriting the 10, right? So this is critical to have a one-shots used in the transition rungs. Okay, so now we are in step 10. All I'm doing now, the action step for step 10 is we're saying we are in auto, and whenever the sequencer is in step 10, we want to turn on a inlet valve on. The inlet valve on is this valve, which when open, we have water filling the tank, right? So to simulate a tank full condition, I just used a timer. I used a T-on instruction, called it inlet valve on time for 10 seconds. Once the timer is done, we'll get a tank full signal, and I'm also turning a blue light on, indicating that we are filling. I will show you that once it falls into this step. We are in step 30 right now, which is so now we are in step 10. The timer started. You can see the tank is filling. That's why this blue light is on. Okay. Now, since the blue light is on, the tank full signal came on. Tank full signal came on. Now we're looking at the next transition condition, moving from step 10 to 20. Once the transition condition from 10 to 20 is tank is full, or the upper level switch being high, right? That's all I'm showing here. Once we are still in auto cycle start, if when the sequencer is in step 10 and we get a tank full signal, we use a one shot and move 20 into the sequencer. Now the sequencer is in step 20, which is heating, right? And that's when the action for step 20 is, hey, we are still in auto cycle start, we are in step 20, turn on the heater. The light is just for indication. And again, I'm simulating the temperature. To simulate the temperature, all I did is just use a timer of 100,000 and use a divide instruction, where we take the accumulator of this timer, divide it by 1000 to give a temperature. And then our transition condition from step 20 to step 30, our transition condition for step 20 to step 30 is temperature being 50 degrees. And that's all this slung is doing. Once we are in step 20, which is a heating step, to index into wash step, we need to wait for the water temperature to reach 50. Once the washer temperature is at 50, the sequencer is in step 30. Again, the actions in step 30, we said the actions in step 30 is just open the outlet valve to wash the part. So that's all we are doing here. Once we are in step 30, we open the outlet valve on, and I'm again simulating a 10-second timer to come up with a tank empty signal. And once the tank is empty, we're going to say cycle complete. Right? We're going to use the one shot. Once the tank is empty, we were in step 30, the cycle is complete. And once the cycle is complete, we have a condition here to index it back into step 10. Okay. So that's how we are looping the sequence from step 10, 20, and 30. Just to see an indicator, just to show it from a visual standpoint, let's trend this one. We right click the sequencer tag and I want to put them side by side. You just drag and drop that. And I want to make my x-axis in minutes. Say apply, okay. You can see the sequencer is right now in step 30, and then it moved to 10 and moved to 20. You can see the heater is on. Once the temperature reaches 50, which is about 50 seconds, it will index into step 30, which will, so we are in step 20. We are at 26 degree. And once the temperature reaches 50, we're going to move into the wash step. 50, and we move into step 30. Okay. And in 10 seconds, the step 30 will go back to zero to step 10. If I hit a cycle stop, everything resets to 0. And when I hit a cycle start, the sequencer starts back at step 10. And then it will index to 10, 20, 30. So that's how simple it is using a sequencer-based logic. It makes your logic easy to understand. Everything is flowing as per the process. And one additional thing I added was if forever a sequencer got stuck in step 10, this step 10 stuck bit will come on. And then that would be easy for the operator or the maintenance technician to see in what step the sequencer is stuck. So say, for example, if it's stuck in step 20, we know the condition is sequencer being equal to 20. So we can go back and see when sequencer is in 20, the transition condition is water temperature. So the temperature probe is wrong or the heater is not working, right? So that's why adding diagnostics is a lot easy. And also you could do how many cycles the machine completed. I just used cycle complete and a counter up to count the number of cycles. So that's how you program a sequencer. Just to recap, each sequencer has steps, and each step has a action step and a transition step. Each step will have a action and a transition, and we need to make sure we are using one shots to make sure we are indexing the sequencer properly. We are not running into race conditions. And also we try to keep one output on in each step and add logic to reset the sequence when a reset button is pushed, or stop the sequencer when a stop push button is pressed. So if you, that's all I have for this video. If you have any questions, please don't hesitate to comment. I will try to get back to the comment. If you like this video, please share and subscribe. I have more videos coming. The next video I'm going to make is how to take this sequencer and create a AOI out of it. I will create a video on add-on instruction set, how to make one. We'll do at least 2 to 3 examples of add-on instruction set. Until then, see you in the next video. Thank you.